All right, double integrals. Let's go. So double integral can be defined a bunch of different ways, but we take a function of two variables and then we say we're going to integrate over some two-dimensional domain. And the two-dimensional domain is something you can definitely draw because it's in two dimensions. And if you want to try to attempt to draw the three-dimensional figure to find the volume, this is one application is the volume, you can try to draw that as well. But I think in the work that you would be doing, I would expect to see the two-dimensional drawing, two-dimensional domain. So, for example, if we're integrating x squared plus y dy dx, and we're integrating y from 0 to 2, and x goes from negative 1 to 1. Would you be able to tell what kind of a region the domain is, the D is? Well, let's take a look at this. And this is how you can start to break it down. We're doing an iterated integral. We're going to integrate with respect to y first. Now, before we actually do the integral, at this point I'm a little bit more interested in trying to extract the domain from here, because I want us to be able to go from an integral to a domain and then from a domain to an integral. So if we take a look at this, the y is going to go from limits from 0 to 2, and then the x's are going to go from your limits of negative 1 to 1. And so if you draw that on an xy plane, because that's where the domain is, we have the limits 0, y is equal to 0, that's the x-axis, to 2. And then we have the x limits going from negative 1 to 1. So this is your domain. In terms of actually doing the integral, that shouldn't be that bad either, right? We're going to go, an iterated integral works from inside out, and so we're going to focus on this integral from 0 to 2 first with respect to y, treating x as if it was constant. It'll be, at the step where you take the integral, x squared is a constant, and so the integral of 5 is 5x or 5y. And you got y squared over 2. You evaluate the y values from 0 to 2, and then you would get 2x squared plus 2. Okay, so that's the inner integral. Notice that when you take the integral with respect to y and then you evaluate, there's no more y's here. There's no more y variables there. Okay? So now that we have that, we take this and integrate this from negative 1 to 1, 2x squared plus 2 dx. So we've got the inside figured out. Now we just integrate this. Now just a regular integral, 2/3 x cubed plus 2x. Evaluate this from -1 to 1. And 2/3 plus 2 minus -2/3 minus 2. So whatever 2/3 plus 2 is, 8/3 times 2, 16/3, maybe. Okay, so that's how we do integrals, right? Any questions? So this is nice if it's a, let's do another example. So here's another example. This time there's variables on the limits. Yeah, the lower one's y. So if we follow the same process and try to figure out, yeah.
What if you flip the intervals around? So the 0 to amount to 0 to on the inside, but you flip the integration from dy to dx. Does it work that way as well?
No. No. There's one very important rule when you're doing iterated integrals. And the very important rule is that the outer limits must always be constants. Very important rule. Outer limits must be constants. Okay? Well, the variables also wouldn't make sense because you're integrating with respect to one variable and then the other variable. So the outer constants have to be constants. The outer limits have to be constants. And if you just switch it, then you would have taken something with respect to y without the y being there. So you just, I put this in bold because I think it's really, really important. I underlined it and put a box around it because I think it's really important. I put stars around it because I think it's really, really super important. And I don't ever, ever want you to make this mistake on the test. Okay? Is that clear?
Yeah.
All right. So let's take a look at how this graph might look like. It looks like our x's are bounded by not just constants anymore, but they're bounded by functions. So the two functions are x is equal to y and x is equal to 2y. And then my y limits are constants that go from 0 to 2. So what I would be interested in looking at is to see how this is going to look like in the graph. my graph x is equal to y, is this 45-degree line. And then I have a graph x is equal to 2y. Y is equal to 1/2 x. So that's going to be going through the origin with a slightly less slope. X is equal to 2y. And then my y goes from 0 to 2. So if I find where that region is, that region would be this little piece over here. Okay? Now, granted, we didn't really have to find the region, but I think it's good exercise to find the region anyways. Because the next thing we're going to have to be able to do is to draw the region and then come up with the integral. All right? Should we finish this integral? All right, so let's do this integral. So there are several ways to do this. One way is to kind of do it the way we did it earlier, just do the inner integral off to the side and then work it out. Another way to do this is maybe to just rewrite everything over again and then do the integral on the inside and then work it out from there. So I might need more space. The integral of 7xy with respect to x, so the x is going to be up to a power and divide by 2. So this is 7x squared over 2 times y. We're going to evaluate x from y to 2y. So that gives us 7 over 2, and then we have 4 y squared, y to the third, and then just a y to the third. So that simplifies to, you can put the 7 halves on the outside, I guess. And the first one will have a 4. Well, this will be a 4 minus 1. That's 3. I suppose you could put the 3 outside, too. Did I do that right?
Yeah, the labs are like including it, so it made it kind of difficult to follow along.
Oh.
Like on the outside, but
Yeah. So this would be 21 over 2, and this is going to be y to the 4th over 4. Y goes from 0 to 2. So let's put 2 in there. 21 over 2. We put 2 in there, we get something. 16 over 4. So that's 4 minus 0, right? And that's it. Okay? All right, let's do another one. This time we'll set up the integral. So sometimes you'll get a problem like this where you just have to set up the double integral, and then they describe what the domain D is. So you can say D is equal to the set of x and y values such that the x values go from 0 to pi, and then the y values go from 0 to sine x. So I think it'd be good to be able to draw this out. A sine function and x is equal to 0 and x is equal to pi. So it looks like we're restricted to this graph over here. Y is equal to sine x. So we have these graphs that encompass this region, and to set up our inequalities, we actually have our inequalities here already, but I want to look at the picture and be able to see if we can come up with the inequalities. And what would seem to make sense to integrate with respect to first? Should we integrate with respect to x or y? And it does kind of make a difference. X. Let's take a look at integrating with respect to x. And here's some other rules of thumb here. Integrate with respect to x first. So would there be an issue if I integrate with respect to x first? So here's what you do. Whatever you want to integrate with respect to first, draw a line parallel to the axis. So draw a line parallel to the x-axis. And what you're going to do, moving from left to right, from negative to positive, is try to figure out when you're going to enter the region and when you're going to exit the region. Okay? So I'm drawing a line with respect to x. So I'm going to get into the function by some function x is equal to something. All right? And then in, and then out. And the two functions that I'll be dealing with would be this part of the sine graph and then this part of the sine graph. So it looks like this is going to be kind of complicated to integrate with respect to x first. It actually, this is the arcsine function over here, arcsine of y. And this would be some other function that's been shifted as the arcsine of something else. And so that's more complicated to deal with. So I'm going to redraw my region. And this time, if we're going to integrate with respect to y first, you're going to draw a line parallel to the y-axis, and then you're going to draw, well, after you draw a line parallel to the y-axis, you're going to ask yourself, you're going to go into the region when y is equal to something, and then out of the region when y is equal to something else. So you go into the region when y is equal to what? So it goes into the region at this point, or at this graph, y is equal to 0. You're going to be inside of the region, and then you're going to get out of the region when y is equal to what? Sine x. So those are the two functions that you're going to have for your x or for your y limits. Okay? So your y limits are going to be from 0 to sine x. So that's going to be your inner limits, your inside limits. What are your outer limits going to be? So your outer limits have to be constants, right? So your outer limits are constants. They go from 0 to pi. Okay? If this was just numbers, what do you think would happen if you didn't have any functions there? If all you had in the limits were numbers, what do you think that means? So if all your limits are just numbers, then your region is a rectangle. If your region is not a rectangle, then not all your limits will be numbers. Okay? All right, here's another popular one. Find the volume of solid in the first octant. Under the plane of 3x plus 4y plus z is equal to 10. So the first octant, what's the first octant? What? The first of the 8 squares, right? So what do they designate it as the first? What are the attributes of the things in the first octant? X and Y and Z values. Think about the first quadrant. What's so special about the first quadrant? They're all positive, right? The X and Y's are all positive. So the first octant could be out of the 8 spaces that you have in space, the first octant is where X and Y and Z are all positive. So that's the first octant. Now this plane is going to be somewhere hovering on this first octant somewhere. We talked about graphing the plane one time. Anybody remember how we might try to graph this plane? Can I find some intercepts? What? So let's find some intercepts. How do I find the x-intercept? Set what? Set y and z equal to 0, right? So if I set y and z equal to 0, what point am I going to intersect here? And if I find the y-intercept, I'd set the x and z equal to 0. And what point am I going to intersect here? And then if I want to figure out where this thing crosses the 10. So I can kind of see this plane intersecting the first octant is like this triangle. Pretty cool, huh? So if I'm integrating this, there's a couple of things that I need. I need to figure out what my domain is if I'm looking at this on xy plane, and I need to figure out what my function is. A little bit more. How do I find my function? What? So your function is a function of x and y. And so if you take your graph and then you get z over to one side, you're going to get your function. Okay. How's this D going to look like? Can I identify D in my graph here? What do you want to draw when you're drawing D? What do you want to start with? With what? I mean, where's it going to be? Where is this D going to be? You understand my question? So if you set your y going from 0 to 5 halves, and then your z, or your x, going from 0 to 10/3, what are you going to get? These are constants, right? You're going to get a rectangle. So before you come up with any equation, what was my suggestion again? How do you want to start doing this problem? No. You want to draw something. What do you want to draw? A region. Where is the region? On the xy plane. So you start with an xy plane. Now, can you try to figure out what this region is going to look like on the xy plane? Looks like a triangle, right? We can get this drawing from the three-dimensional drawing that we have. Can you see that? So what are some of the key features of this graph? Here's my x and y. Do I know what my x-intercept is? 10/3, right? Do I know what my y-intercept is? 5/2. So you can find the equation of this line by using point slope. There's another way to do this using this function, using this graph, using this plane. Where am I on the xy plane? On the xy plane, I have z is equal to 0, right? So this equation over here is going to be 3x plus 4y is equal to 10. That's this line right here. Okay. So now the next question is, well, I think I can identify what my region is. The next question is, how do I want to integrate? What variable do I want to integrate with respect to first? You want to integrate with respect to x first? Doesn't matter? Let's pick one. Integrate with respect to y. I'm going to draw a line parallel to the y-axis. That's your first step, right? Well, you had a bunch of other steps before this one, but that's your next step. So you decide that you're going to integrate with respect to y first. So you got to ask yourself, I'm going to have a couple of equations, y is equal to something and y is equal to something else. I need to figure out when I'm going to enter my region. Y is equal to what? Y is equal to 0. I will enter my region when y is equal to 0. And then I will be inside of my region until at some point I'm going to exit my region. And it looks like I will exit my region on this plane or on this line, so I need to solve for y. Okay? So that's my inner limits. Now that I can go in through my y, I can make my y cuts all across. But I need to know when I'm starting my x and when I'm ending my x. So what are my x limits? 0 to 10/3. Always have to be constants, right? Outer limits are constants. So let me set up the integral. It looks like my integrand is 10 minus 3x minus 4y. And I'm going to integrate with respect to y first. So that's a dy. My y limits go from 0 to 10 minus 3x over 4. And then I'll integrate, my outer limits will be with respect to x. And my x limits are going to go from 0 to 10 over 3. Okay, are there any questions? Yeah, you could have done this with respect to x first also, and you would have just about the same amount of work. So if we were to do this with respect to x first, we would draw a line parallel to the x-axis. X starts off where? At 0, and we'll be in the region until you get out. So here you need to solve for x. So x is equal to 10 minus 4y divided by 3. And then your y limits would go from where to where? 0 to 5 halves. Constants. All right? So I think you should give this a try. I got a worksheet for you.